In this tutorial, we will be discussing Fischer projections. A Fischer projection is used to represent carbohydrates. They put the most oxidized group on the top, which is why you'll always see the COO, the carbonyl group, closest to the top. If it's an aldehyde, it'll be on the very top. If it's a keto, it'll be in the middle somewhere on the top. It shows all the chiral carbons as an intersection of vertical and horizontal lines, so they basically look like big plus signs. It shows the hydrogen and OH groups on the horizontal intersecting lines, and places the CH2OH group at the bottom. They also do a D and L notation, and they follow the OH group on the chiral carbon farthest from the carbonyl group. If that OH group is on the left, it's an L. If it's on the right, it's a D. So if we look here, here's the carbonyl group. It's always on the top. Each one of these crosses is a chiral carbon. Notice they start counting the carbons from the very top at that CO bond. So on the fourth carbon here, that's going to be our last chiral carbon, because the next one, CH2, because of that 2, is not considered chiral. The OH group is on the left-hand side, which is why it's L. If it were on the right-hand side, like it is here, it's a D. This is glucose. It has 6 carbons. The 5th carbon is the last chiral when you count from top to bottom, and the C-double-O bond is always on top. The OH here is on the left, which is why it's L. The OH here is on the right, which is why it's a D. So let's take this Fischer projection and identify the monosaccharide as D or L. Well, here's our carbonyl group. It's at the top. 1, 2, 3, 4, 5. The 5th carbon is the last chiral. It's on the right-hand side, so it's going to be D. Identify the number of chiral centers. There's 1 here, and there's 1 here, so there's 2. Identify the monosaccharide as L or D. Well, I look at the last chiral center. It's on the OH is on the left, so it's L. Glucose is, we're going to talk about 3 different monosaccharides: glucose, fructose, and galactose. Those are the 3 most common ones, and so that's why we're going to focus on them. Glucose is found in corn syrup, in fruits, and honey. It's an aldohexose. Aldo means it's an aldehyde, which means the carboxyl group will be on the very top. Hex means that there's 6. So there's 6 carbons there. When we use it in blood sugar, or we refer to it as in blood sugar, we actually call it dextrose. It's a building block of sucrose, lactose, maltose, and in polysaccharides such as cellulose and glycogen. Remember, disaccharides and polysaccharides are larger molecules made up of these monosaccharides. D-fructose is made from sugar, is obtained from sugar, sucrose. It's a ketohexose, which means this is going to be a ketone, which means that double bonded oxygen will not be on the top, but it's still going to have 6 carbons. So here are 2 different pictures. Notice this one's an aldehyde and this one's a ketone. Fructose is the only ketone of the 3 major ones. So galactose also is an aldehyde. I want you to take a special look at the 4th carbon here on glucose. 1, 2, 3, 4. Notice the OH is on the right. That is the only way you can tell the difference between glucose and galactose. So that's what you're going to want to be looking for. Here it is. This is galactose. 1, 2, 3, 4. The OH is on the left here. whereas with glucose, it was on the right. That's how you know the difference between glucose and galactose, and that is genuinely the only difference. So that's a very special thing that you want to look for. Galactose is also an aldehyde, so it's an aldo. It's still 6 carbon, so it's still hexose. So you notice that both galactose and glucose are aldohexose. It's not found free in nature. It's obtained by looking at from the disaccharide lactose. Has a similar structure to glucose except for that one OH. And those are your three most common monosaccharides: glucose and fructose and galactose. You need to know the difference between the 3 of those chemically. So for instance, both galactose and glucose are aldehydes. The double bonded oxygen will be on the top. Fructose is the only one that's a ketone. And then the one difference between galactose and glucose is that 4th carbon.